Hi everyone, this is Mr. O'Gall, and in this video we are going to be looking at the area and perimeter of different types of polygons. Alright, so let's get started by defining the vocabulary word area. Now this is probably a review from last year and the year before, but I'd like you to pause the video, write this definition down in your notebook, and hit play when you're done. Ready, pause. Alright, and there are two formulas for the area that I'd like you to copy down. This is the area of a triangle. So pause the video, copy this down, hit play when you're done. Ready, pause. And this is the second formula I'd like you to copy down, which is the area of a parallelogram and a rectangle. Please note that in a rectangle, the base and height are self-explanatory. However, in a parallelogram, the height is from the top to the bottom. It is not the slanty part. I repeat, it is not the slanty part. Pause the video, write this down, and hit play when you're done. Ready, pause. Okay, so let's say we want to find the area of the shape here using the unit squares. Now, if I tried to count them, I'd run into a problem because this box right here isn't full, this isn't full, this isn't full, so I have to look at my area in a different way other than counting boxes. And one thing I can do is taking my shape and dividing it into smaller shapes that I know how to find the area of. So here in the middle we have a rectangle. We know that the area of the rectangle is base times height. And then there are different sets of triangles, and we know that the area of the triangles is 1/2 base times height. Now remember that in my triangle, this right here is going to be the base, and this is going to be the height. Same with the green triangle. Pause the video, calculate the area, and hit play when you're done. Ready, pause. Alright, you should have gotten that the area of the top triangle is 8, the rectangle is 32, and the bottom triangle is 12, and this gives us a grand total of 56 units squared. If you did not get this correct, I'd like you to go back and do it again. Alright, now I'd like you to write the definition of perimeter. Again, this might be a review from last year, but I'd like you to pause the video, write this definition down, and hit play when you're done. Ready, pause. And now let's go back to our shape and try and find the perimeter of it. Some parts are going to be simple, like this part right here. You know that the perimeter is simply going to be 4. However, how can I figure out this section right here? Well, if I have a right triangle and I know that this side is 2 and this side is 3, I can use the Pythagorean theorem to find the hypotenuse. And I would do that like so. Now I'd like you to pause the video, find the rest of the perimeter, and hit play when you're done. Ready, pause. Alright, so now we're going to get into regular polygons. A regular polygon is a polygon that has congruent sides. That means all the sides are the same length. And it also has congruent interior angles, which means all the angles are the same. Pause the video, write this definition down, and hit play when you're done. Ready, pause. Alright, now let's look at the area of a regular polygon. Let's consider a regular pentagon. That means I have a 5-sided shape. Now the side I'm going to label as S. And when I divide it, I'm going to break it up into 5 isosceles triangles, which means that my 2 other sides are going to be congruent. First question, how can I find the area of one isosceles triangle? Well, that's pretty simple. We just use a formula for area. 1/2 the base, which is S, times the height, which they've labeled for us as A. So if I want to find the area of the entire pentagon, I'm going to have 5, because there's 5 triangles. 1, 2, 3, 4, 5. 5 times 1/2 the side times the A. and the A is going to be the height. All right, now I'd like you to try to find the area of this six-sided shape. So pause the video, use the same steps to find the area of the hexagon, and hit play when you're done. Ready, pause. And your final answer should be that the area is equal to 3SA. Pause the video. If you did not do this correctly, go back and check your work and hit play when you're done. Ready, pause. All right, now we could do this again to find the area of a regular polygon with 5 sides, 6 sides, 7 sides, 8 sides. But in order to save us a little bit of time, I'd like you just to pause the video, copy this chart down, and hit play when you're done. Ready, pause. And the final thing we have to do today is generalize the area of a regular polygon. And to do that, we have to define a new vocabulary word. This word is called the apothem. And the apothem is the perpendicular segment from the center of a polygon's circumscribed circle to the side of the polygon. You may also refer to it as the length of a segment. So let's look at what this means in more detail. Let's say I have a circumcised circle. All right, now I know my circle is not perfect, but if I go from the center of my circle to the side, I'm going to get a 90-degree angle, as in the side and this line right here, which we're calling the apothem, are going to be perpendicular. They're going to form a 90-degree angle. So to find the area of a regular polygon, we have A is the apothem, N is a number of sides, which means really the number of triangles we're going to be able to create. P is the perimeter, which is the distance around the entire shape. And S is the length of each side. And I get this beautiful formula. Area is equal to 1/2 A times P, the perimeter, or 1/2 the apothem times the length of each side, or the number of sides. Now these two formulas are equal because we know that the perimeter is equal to all the sides. So if the length of the side is S, and I'm going to add it by the number of sides, it's the same as multiplying by the number of sides. All right, here's the slide again. It's all clean. I'd like you to pause the video, write this down, and hit play when you're done. Ready, pause. All right, you're all done. You have officially learned how to find the area of any regular polygon. Great job!